In this lesson, we're going to talk about dependent events. So once again, looking at our notes, probability, you can have one event, which is a simple event, which is just doing one thing. You can have more than one thing, so you can have two or more events, and that's signified by the word and. Remember, the word or means you just add them together, so like heads or tails, you just add them together, but it's still a simple event. It's one fraction. With two or more events, you have the word and. You can have an independent event and you can have a dependent event. An independent event does not change. A spinner doesn't change. A dice doesn't change. If you pull something out and put it back in, it doesn't change. That's an independent event. But with a dependent event, it is going to change. So as soon as you do one thing, the second time you go to do it, it's going to be different than the first time. So if the outcome of one event does influence the outcome of the other event, this is like if your parents moved to Alaska, because you're a dependent, it does affect you. You do also have to move to Alaska. The second event is considered only if the first event has already occurred. So here's some examples. If you're dealt a king from a deck of cards and you do not replace it, this is the big key right here, you do not replace it. If you do not replace the king back into the deck before selecting a second card, so already because you don't put it back, the number in the deck has changed. The chance of selecting a king the second time is diminished. That means it's less, because there are now only 3 kings remaining in the deck. So there were 4 the first time. The second time there's only 3. Other examples of dependent events are, but not limited to, choosing 2 marbles from a bag but not replacing the first after selecting it, and picking a sock out of a drawer and then picking a sock without replacing the first one. So see how it changes? Every time you pull one, it's going to be different for the second one. So here's the formula. The probability of 2 dependent events is found by using this formula here. The probability of A and B, so there's your and, which already says that it's more than one event. There's going to be 2 fractions, 1 fraction for A and 1 fraction for B. First you find the probability of A, and then you're going to multiply it by the probability of B after you take A out. So example 1, you have a bag holding a blue ball, a red ball, and a yellow ball. So I'm just going to draw the bag right here. So here you have a bag, and it has a blue ball, a red ball, and a yellow ball. Whoops. What is the probability of picking a blue ball out of the bag? So that's the first one on the first pick. So what is the probability of picking a blue ball out of the bag on the first pick? Then without replacing the blue ball, so we're not going to replace it, picking a red ball on the second pick. So we have a blue ball and a red ball without replacing it. So here's your, what's the probability of blue and red? It's the probability of blue times the probability of red after the blue. So the probability of blue here, there's 1 blue out of 3 in the bag, so it's 1 out of 3. But then what you do is you take 1 blue out, so there's no longer this blue here. We've taken it out. And so when you go to multiply the second one, there's no longer 2 in here. There's no longer 3 in here. Now there's only 2. So this denominator is 2, and there's 1 red ball in there. So now it's 1 out of 2. So because it's dependent, it's changed for the second one. Then of course we're going to multiply. 1 times 1 is 1. 3 times 2 is 6. So you have a 1 in 6 chance, which is 0.16 repeating, and that's a 17% chance, which is unlikely. Example number 2, you have a deck of cards with 4 kings. So here's your deck. You have 4 kings. You have 3 queens. And you have 2 jacks. What is the probability of picking a jack on the first pick, then without replacing the jack, picking a king on the second pick? So what's the probability of picking a jack and then a king? So first we're going to find the probability of the jack. So to look at it here, you have 2 jacks out of 4, 5, 6, 7, 8, 9. 2 out of 9 cards. So there's 2 jacks out of 9. Now here's the part where some people mess up. When they take them out, they want to take out both jacks, but you're not going to do that. Remember, you're only picking one time. So you're just picking one jack out of here. You're going to pick out one jack, which means that there's no longer two, there's only one jack left. So don't take both of them out, just take one of them out. So whenever you pick the first time, you're picking one time. So you're going to pull one jack out. So then what's the probability of picking a king after you pulled out that jack? Well, up here the kings weren't affected, there's still 4 kings. But instead of 9 cards, there's only 4, 5, 6, 7, 8 cards because we pulled that one out. So there's a 4 out of 8 chance. So 2 times 4 is 8. 9 times 8 is 72. So you have an 8 in 72 chance of doing this. So 8 divided by 72 is 0.11. That's an 11% chance of pulling a jack out of a deck of cards, out of these cards here, and then, or a king and then a jack. Wait, a jack and then a king. So this is unlikely. Example number 3. There is a bag that holds 12 Snicker bars. So you have 12 Snicker bars. You have 5 Skittles bags and 9 Hershey bars. What's the probability of the first person picking, what's the probability of the person, I don't know why it says first, the person picking 2 Hershey bars in a row? So this one you're not going to pick them both at the same time. This is like the same thing as saying what's the probability of picking a Hershey and a Hershey. So split that up. Don't let that two confuse you. So split it up. You're going to pick a Hershey and a Hershey, and this one it should say without replacing. So we're not going to replace this. So the first time you look at it, there's 9 Hershey bars, and there's 12 and 5 is 17, and 17 is and 9 is 26. So the first time you pick a Hershey bar, there's a 9 out of 26 chance. Then you're going to take one Hershey bar out, just one Hershey bar out, which means there's no longer 9, there's only 8. And so the second time you pick this Hershey bar, there's no longer 9 Hershey bars, whoops, that should be times, there's only 8 Hershey bars, so there's an 8 in 25 chance of picking the second Hershey bar because it's changed. So 9 times 8 is 72, 26 times 25 is 650. So there's a 72 in 650 chance of doing this, which is a 0.11, which is an 11% chance because you move that decimal over twice. So it's unlikely that if you stick your hand in here and you pull out 2 Hershey bars, that you're going to pick out one Hershey bar and then another. This example here says a deck of cards has, typo, 52 cards, half are red and half are black. What is the probability of picking 2 red cards in a row without replacement? So again, don't let this 2 red here confuse you. If it does, rewrite it as what is the probability of picking a red and a red, because you're not going to pick 2 cards out at the same time. You're going to pick them out one at a time. You're going to pull a red and then you're going to pull a red. So looking at your first time for this red here, you have a deck of 52 cards. So altogether you have 52. Half of them are red and half is black. So 52 divided by 2 is 26. So you have 26 reds and you have 26 black cards. So the first time you go and you pick a red, you have 26 reds out of these 52 cards here. Then you're going to take just one red one out. You're going to take out 1 red card, which leaves you with 25 red cards because you're just taking 1 out. Don't take out all 26, you're just taking 1 out. Then the second time you're going to go to pick, you're going to multiply. For this red one here, you no longer have 26 cards, you only have 25 cards. And you no longer have 52 cards, you only have 51 cards because you pulled that 1 red out. So 26 times 25 is 650. 52 times 51 is 2,652. So 650 divided by 2,652 is 0.25. If you move that decimal over 2 places to the right, that's a 25% chance. You have a 25% chance of pulling 1 red card and then pulling another red card out of a deck of cards, and it's unlikely. You have a better chance here than you had a better chance here, but it's still unlikely. And then the last example, it says a deck of cards has 52 cards. Half are red and half are black. What is the probability of picking a black card and then a red card without replacement? So let's see how this is different. So the probability of a black card, again, if there's 52 cards and half of them are red, so 26 are red, 26 are black. So what's the probability of picking a black? You have 26 out of 52 cards. Then without replacing it, so when you go to pick this first black one, you're going to pull this black one out. You're going to pull out one black. There's no longer 26 cards, there's only 25 cards. When you go to pick the red one on the second time, there's still 26 red, so that hasn't changed. But instead of 52 cards, there's only 51 cards. So there's only 51 cards here. 26 times 26 is 676, and 52 times 51.
Ms. Overstreet, could you come to the office, please? Ms. Overstreet.
Is 2,652. So we're going to divide that. 676 divided by 2652, and that gives us 0.25. And so we're going to move that decimal over, and you also have a 25% chance here, which is unlikely, of pulling out a black and then a red.
Stop.